Okay, so let's start our class now. Okay, some of your friends are still coming in. So, you guys ready? Hello.
Yes,
Yes,
sir.
sir.
Okay,
Yes,
so,
sir. Yes,
okay.
sir.
Okay, so let's start our lab session now. Okay, so today, okay, so we're going to continue chapter 3. So I guess before we start, I guess I already notified you guys yesterday about our midterm test that will be held next week on Wednesday. Okay, so most question will be objective, but it's not an easy objective. It's quite difficult actually. It's not just choose the answer. Sometimes you need to think a lot for the answer. So just need you guys to prepare. Okay, it's up until chapter 4. So this week we will enter chapter 4. And please make sure by next week you submit all the lab sheet for up until chapter 4. Okay, because those lab sheet I will use them to graduate your lab assignment. Okay, so make sure you guys fulfill all the requirement there. Okay, so today we will discuss the lab sheet for the remaining point. Okay, and for today class, okay, we will use what we call open source software called Logisim. So this Logisim software is basically one of the most useful software that we have found to be used for this class. So later on for your projects, okay, we expect you guys to develop a report using this as well. Okay, so let's start with where we left last week. Okay, so you guys can see my slide here, right? Okay, you guys see it? Okay, you guys see it?
Yes.
Okay, good.
Yes.
Yes,
Yes.
sir.
Okay, so okay, so last week we talked about the gates, everything, and then we have the Boolean algebra, okay, and then we have the Karnaugh map. Okay, so last week I did put some videos on Karnaugh map, and I expect you guys to finish up until this point already. So last week also I introduced to you guys half adder and full adder. Okay, so this one, okay, half adder and full adder, okay, so it's not a difficult task, okay, for you guys to do, but you need to understand it clearly. Okay, so today we'll start with 3.4, which is half adder. Okay, half adder and full adder. This one is full adder. Okay, so firstly, okay, we need to draw the truth table first. Okay, what kind of truth table we're going to draw? So I'm going to insert table from this PowerPoint here. So table. So we have 3 inputs and 2 outputs. So we have 4, 5, 3 inputs. We need 7. 1, 2, 3, 4, 5, 7. Okay. Okay. So we have this table here for you guys to use. Okay, so table design, okay, this one. Okay, so now first we see that we have carry in, C in. So in, okay, and then we have, okay, we have PQ as an input. Then we have sum and C out. Okay, so let's pull this a little bit. Okay, so let's make this one a little bit colorized. This one is for output. So output, this one is for input. What kind of color should we choose? Okay, this one's fine. Okay, so we start the number from 0 until, because we have 3, so you have up until 7. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. Okay, oh, not 2. 1, 1, 1, 0, and I forgot another one. Insert 1 columns and insert 1 rows below. Okay. Okay, so we have here 1, 1, 1. Okay, so now okay, what we expect to have is that, okay, for 0, 0, 0, the sum will be 0, okay, and carry is 0. Okay, then 0, 0, 1, the sum will be 1, carry is 0. 0, 1, 0, sum also 1, carry is 0. And here, sum is 0, 1, 1, sum is 0, carry is 1. Okay, so here is sum is 1 and carry is 0. Here sum is 0, carry is 1. Okay, sum is 0, carry is 1. Sum is 1, carry is minus. Okay, so in case you want to ask anything regarding question, you can just raise your hand, okay, for the in the Google Meet, so you can ask anything. Okay, so this is basically the truth table of what we want to do. Okay, so let's try and create the, what you call it, this one is for the calculation, 1 plus 1 equal 2. Okay, so now in order to design the circuit, okay, in order to design the circuit, okay, in order for you to design the circuit, okay, we need to do some circuitry over here. Okay, so now, okay, to design the circuit, you need to remember what half adder looks like. Okay, so half adder is basically looks like this. You need one XOR gate. Okay, one XOR gate to generate the to generate the okay, XOR gate is used to generate the uh, sum. Okay, and for AND gate we use to generate the carry. Okay, so here, okay, we create the XOR gate first. Okay, you can create everything in PowerPoint, so it's easy for you guys. So this one, in case of PowerPoint shape, it's kind of ugly. If you want to edit them, you can click like edit points here. Okay, you can pull it back. Okay, you can edit it to make it prettier and look more like XO gate. Okay, so this one is kind of a little bit troublesome, but okay, you can make it a little bit more pretty. Okay, this one is OR, XOR, sorry, it's XOR. Okay, so okay, this one make it a little bit thick. Okay, so you got yourself an XOR gate. So this one is XOR. So the purpose of XOR is to create the sum. And then you need another one to create the carry. So carry, okay, if you see for sum, okay, so here you see that this one is a XOR gate where 1 1 only you got 0. And for carry, you need for 1 1 to get 1 other than that is 0. So here you need an AND gate. Okay, you need an AND gate. So AND gate looks like this. Okay, so we rotate the AND gate downwards here. I think it's better to make it this way. Okay, next to each other. So in this case, okay, you got the second shape. So first shape, okay, let's put in, let's do the PQ first. Okay, we have this one from P. Okay, this one is from Q. Okay, so and then we need to put in another shape. Okay, from this one into this one. Okay, usually when we have a connection, usually I put a circle here, black circle. So this one to represent that we have a connection here. Okay, so that you will not confuse the one connected and the one not connected. Okay, so then we have a second one for Q. Okay, so put a black connection as well. Okay, so you have P and Q coming in, and then we insert. Okay, we insert the output. Next. Okay, this one is second output. Okay, so now you have what you have here is the half adder. Okay, this one is P. Okay, and next one is Q. Okay, and okay, here is sum. And this one is carry out. Okay, so you have this one as the first half adder. Okay, so actually you have two half adder here to create what we call a full adder. Okay, so just group this one first. Group. Okay, so let me shrink it a little bit. Okay. Okay, we shrink it a little bit. So now, okay, so we create another one up here. Okay, so this one have to be back. Okay. Okay, now when you see, okay, we have the output from sum, okay, sum from the first half adder entering the Q section for the second half adder. Okay, so we remove this one, we remove this point here. Okay, we remove this Q. Okay, so then next one, we have the command out, the C out, carry out from the first half adder going to the OR gate. So we have one OR gate here, out here. Okay, that connects and combine both of the output from your N. Okay, so we have another one. Okay, so now almost finished. Okay, so you just change the last one here to carry in. And the C out is going to be here. Okay, so now you finish your design. Okay, so here we have what we call a full adder. Okay, so you have XOR gate, okay, two XOR gate, two AND gate, and one OR gate, so that this will become a full adder circuit. Okay, so how does full adder circuit work? Okay, so let's create the equation first here. So we can create equation here. So let's put X PQ Q. Okay, I think just to save some time, I just going to copy what I did in the lecture slide before. Okay. Okay, so here is what I did before in our lecture slide. Okay, so now, okay, they want us to demonstrate, okay, 1 plus 1, 0. 1 plus 1 is 2. Okay, since 1 plus 1 is 2, we don't have anything at carry in yet. Okay, carry in, we don't have anything. So we have P here and Q here. Okay, here is your sum. So this is a carry out. Okay, this one is carry, basically carry. So the orange one is the carry in. Okay, C in orange is carry in, C in yellow is carry out. So if you see here, 1 plus 1, the answer is 1, 0. So 0 going down and 1 is going back up. Okay, 1 is going back up. So here is where you can see that here, okay, we have conducted the 1 plus 1 equal 2. Okay, so this is the calculation that I need from you guys to fill in. So once you finish, okay, so please make sure you submit, okay, the full answer, okay, later on based on what I've given you here, okay. So finish with question 3.4. So let's go ahead with question 3.5. Okay, now, so this one, you can download the software from Logisim. Okay, so there's a link here. Okay, I already downloaded the software, and okay, I'm going to share you here in my screen. Okay, I will close my PowerPoint. I think I will share my full screen. Okay. Okay, so I think you guys can see my full screen now. Okay, so this is the Logisim that I have. Okay. Okay, so what does Logisim do is that Logisim will help you to simulate, help you simulate a logical circuit so that you can test whether the input or output is working or not. Okay, so let's try to draw the same design that we have here. Okay, in this case, so I'm telling you guys in the question is to build this kind of circuit. Okay, run the software and try to create the above design. Okay, so in this Logisim, okay, you have a lot of functions here. You have wiring, gates, plexes, arithmetic, memory, input, output, and base. So later on during your project, also you can utilize this one for making your own design. So firstly, okay, in order to start, we look at the gate first. Here you have two AND gate. Okay, two AND gate, one AND gate, and another one AND gate. So when you design the AND gate, you have how many inputs for this each AND gate? You have two inputs. So you make sure that, okay, you have the number of inputs set to 2. Okay, number of input is set to 2. Okay, so let's put this button back. Okay, number of input is set into 2. So here the second one also, you make sure that you change the number of input also set into 2. Okay, so you have 2 input for this AND gate. And then you have one OR gate. Okay, put here one OR gate. So number of input also 2. Number of input also 2. Okay, so now you attach the OR gate with the AND gate first. Oh, okay. Okay, we don't have anything yet here. So wait a little bit. Okay, now next you need two NOT gate. First NOT gate and the second NOT gate down here. Okay, from here entering here. Oops, this one is not good. So when you deal with Logisim, you must make sure that your connection is correct, or else this one will be a lot of trouble later on. Let's just do this again. Copy. NG. Okay. Okay, so this is the second gate. Okay, so next, okay, you have to make sure that this one connected to here, and this one is connected to here. Okay. Okay, you see that. Okay, to represent connection available, the connection place, the place where it's connected, you have a black dot here. Okay, this one you don't have the black dot, means that it doesn't connect. So next, okay, you have, in this case, you have, oh, okay, in this case, you have two inputs. Okay, you have two inputs here, so we go into wiring and we put in pin. Okay, and then we put another pin down here. Okay, and then we put in, and this one at the end is what we call also the pin, and this one must be facing west. Okay, 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 okay. So let's take a look what happened. So okay, when you press this one, the finger button, now you are controlling this. Okay, so you have X and Y here set into 0. You got the output here is 0. If you set it to 1, become 1. If you set it to 1, 1, it becomes 0. If you set it to 1, 0, oh wait, 1, 0, it becomes 1. Okay, so this is example of a circuit that you have inside the Logisim. Okay, so you can have a lot more circuits according to whatever design that you want. You want to create a half adder, full adder, or you want to create what you call it, comparator, okay, subtractor. You can do it with this, and this one is only for 1 bit. Okay, you can do it up until in case for this AND gate, you can go here. If you look at data bit, you can go up until 32 bit. Okay, 32 bit means 32 bit you have a lot of input inside the gate. Okay, so in this case, I just create it using, okay, how many bits here? Okay, 1 bit. Okay, so here 1 bit means that the one traveling into the AND gate from one pipe here is only 1 bit. Okay, you can have up until 32 bit. Okay, and you get the answer of two 32 bit merge. Okay, so you can use this one to create your own project later on. Okay, so I would like to see that you create this kind of projects. Okay, and later on, I think you can copy or paste. If you cannot copy and paste, no, you cannot copy and paste. You can use to insert your answer inside the PowerPoint. You can just use insert, screenshot, screen clipping. Okay, screen clipping, and you can clip back inside your uh, Logisim. Okay, and then it goes into here. Okay, so you finish it already. Okay, so this one is not pretty because you have this white box here. So let's do it again. Okay, if you want to copy the without the white box, okay, click screen clipping. Okay, and then you have to make sure that you tick the fingers. Okay, the fingers, not the arrows inside Logisim. Okay, and then you copy and paste it into your PowerPoint. Okay, so now you're finished. Okay, so this is example of using Logisim inside the equation, inside the lab task. Okay, lab sheet. Okay, so now, okay, let's proceed to the next task. You export to image and save it into PowerPoint. That one time consuming. I prefer to copy and paste only. Okay, you can copy and paste using insert screenshot. It's easier actually. Okay, so now let's start a new task. Okay, here. Okay, close the last one. Discard. So I want to create a half adder and a full adder based on the question inside your task here. Okay, understanding half adder and full adder. Construct the circuit using Logisim. Use this page to design your circuit. Okay, so let's create a half adder and full adder. So half adder, usually you have XOR gate with two inputs. Okay, let's create a small one first. A half adder, and then you have AND gate. Number of input 2 again. Okay, 2, not 5. Okay, so here you have, okay, you have let's put in the input first. Pin 1, pin 2. Okay, so this one will connect to the first port. Second one will connect to the second port. Okay, this one connect here, and this one will connect here. Okay, so this one is a carry out. Okay, change it to west. Okay, and then okay, so for pin to become output, you need to change it into output. Don't forget to change it into output. Okay, so this one, oh, not connected. West. Okay. Okay. So you finish your first half adder. Okay, how do you know it's a half adder? Okay, 0, 0 become 0 and 1. Okay, 0, 1 become sum is 1, carry is 0. Okay, 1, 1. Okay, sum is 0, carry is 1. Okay, so this is what we want. Okay, this one represent 2. Okay, so this one is a half adder. Okay, half adder. So half adder, usually they involve only addition for 1 bit. Okay, so for full adder, okay, we usually use it to add a lot more. So just copy. Okay, my keyboard is not okay. Is it okay? Okay. Okay, good. So this one, okay, you remove this one first, remove this one and attach this one to this one. Okay, and this one going in, carry in. And then you have another OR gate, not XOR, OR. Okay, that adds to input as well. Okay, so this one, okay, this one is the, okay, on the top here is the sum. Okay, this one is the carry. So this one, in case you didn't have for the first, okay, in case you have, like for example, okay, equation like this. Okay, you have equation like this. So you see that the first one, first bit on the right side usually 0. Okay, carry is usually 0. We don't have carry at the beginning. So usually inside your, okay, in case like we're going to add 2 bits. Okay, we're going to add 2 bits. Okay, so this is the first bit. Okay, X and Y. So this one is where we have X1, bit, first bit of X. Okay, X1. Okay, and then we have Y1. Okay, so this means that, okay, X and Y, like inside this question here, okay, so this one is X1, this one is Y1. Okay, this one is X, P is X, Q is Y. So this one is X1, this one is Y1. Okay, we might have X2, Y2 over here. Okay, so we want to create, maybe if you have more, okay, maybe if you have more, you need to do like this. Okay, you have a second bit. So this one is X2, Y2, Y2. Okay, so the carry from the first one is connected to the second bit. Okay, so here if you have 0, 1, for example, you get the answer here, and it keep on carry. So this one, X2 and Y2. Okay, so usually for the first equation, okay, we usually have only half adder. Okay, half adder. Second one, we have full adder. So this one usually we don't have. Okay, we only have something like this only for the first bit. Okay, we don't have this yet. Okay, we only have half adder for the first bit. Okay, for the second bit we have full adder. Okay, and then for the third bit, in case you have 3 bits, okay, in case you have 3 bits, okay, you want to add 3 bits, okay, means that you're going to add up until 7 plus 7, okay, 7 plus 7. 1 bit you can only add 1 plus 1, okay, then the answer also you cannot display. But 3 bits you can add up until 7 plus 7, so you need the third full adder, the second full adder to represent the third bit. So this one is X3, Y3. Okay, so and then we pull out the carry from here, enter into the next one. Okay, so this is the answer for the first bit, this is the answer for the second bit, and this is the answer for the third bit, addition for the third bit. Okay, so in case you are adding, okay, like for example, okay, let's open the slide again. Okay, you want to add, for example, 3 bits like this. Okay, 1, 1, 1. Let's do it 1, 0, 1. Add with 1, 1, 0. Okay, you want to do this one kind of calculation. Okay, so what happened here? Okay, you should get you need the half adder. Okay, this one is x, this one is 1. Okay, and on top of here you have carry. Okay, so 1 plus 0, okay, down here supposedly your sum. Okay, so in this case here you have 1 plus 0 supposed to be 1, 0 plus 1 supposed to be 1, and 1 plus 1 supposed to be 0. Okay, and oops, and you have, okay, here is at the beginning you don't have any carry, here you have carry 0. Okay, here you have carry 0 as well, and at the end you have 1 extra here, carry 1. Okay, you have 1 extra here for carry 1. Okay, so to simulate this, okay, we have this Logisim equation. So the first x is, okay, the first x here is 1, so here is 1. The second x here is 0, and the third x here is 1, so the third x is 1. And y, the first y here is 0, okay, 0. The second y here is 1, the third y here is 1. So now what you get here, okay, is 0. If you look at the output here, okay, you have the first output is 1, the second output is 1, the third output is 0, and you have 1 carry extra. Okay, so if you look at the PowerPoint, you have the first output 1, the second output 1, the third output is 0, and you have 1 carry extra. So this is a correct design for the half adder and the full adder. Okay, so for the beginning, okay, for the beginning you need to use half adder because we don't have carry for the first bit, carry in. For the second bit and above, you will have a carry in for the full adder. Okay, so in case your PC is up until 64 bit, you will have up until 64 half adder arranged side by side to do an addition. Okay, so this is a lot of transistors involved. Okay, so once you finish here, okay, you can just insert, okay, screenshot, screen clipping. I like to use screen clipping more than save as image. Okay, save my hard disk space. Okay, then you finish it. Okay, you got the design here. Okay, okay, so finish with your lab task. Okay, so make sure you try and do this by yourself. Okay, and then submit it to me soon. Okay, tomorrow is the deadline, so use your time to do this by today and tomorrow, and submit the task tomorrow. Okay, so do you have any questions so far? Any question? Any question? No question?
No, sir.
Okay, so far you can understand how to do it?
Yes, sir.
Okay, so make sure you can download this. Make sure you can download this, okay, the software, and try to build them by yourself. It's not that difficult actually. Okay, so later on we might have, like for example, we need to use our memory. Okay, like this flip-flop, we have a lot of flip-flop register counter for us to simulate the memory inside a CPU. Okay, so make sure you guys get familiar with all these components here. Oh, you want to see the last two slide back? Okay, this one? Okay. Okay. So don't worry, I'll upload the video later on inside YouTube, so you can refer back to how I did it inside YouTube later on. Okay. So I see you guys next time. Okay, I already got your attendance here. Okay, in case there are no questions, I'll see you guys later then. Okay, bye-bye. Assalamualaikum.
Alright.
Waalaikumsalam.
Thank you,
Professor,
sir.
sir. Thank you.